Hey everyone. So now we will solve the third problem of this contest, which is minimum cost to move between indices. The problem reads as you are given an integer array nums, where nums is strictly increasing. For each index x, let closest of x be the adjacent index such that abstract of difference between nums of x minus nums of y is minimized. If both adjacent indices exist, then choose a smaller index, right? Uh, let's first read the problem, then we will go part by part what the problem statement asks and what we need to do in that, right? So from any index x, you can move in two ways. You can move to any index y with cost of abstract of this nums of x minus nums of y, or to the closest of x with cost of 1, right? You are also given 2D integer array queries where query of I represents li to ri. For each query, you need to calculate the minimum total cost to move from index li to ri. Return an integer answer where answer of I is the answer for ith query. An array is said in strictly increasing if it is strictly greater than the previous one, and the absolute difference between two values of values are x and y are defined as abstract difference of both of the previous abstract difference of x minus y, right? So let's look at an example, right? Let's take this one seems to be a better one, right? Give me a second. So this was our problem statement, and if you look at it, it says the nums array is given, queries is given. They say first you start from 3 and go till 0, right? And these are the queries, right? So let's first try to create the closest array, right? So if you are standing at this position, you don't have a previous adjacent element, so the next element will be a closest element, right, which is 1, right? If you are standing at this position, you have two values, either to go to the left or go to the right. If you go to the left, the difference is 2. If you go to the right, the difference is 1. So you should definitely go on the right, and it will be on index 2. Now, if you are standing at this 3, you can go either back or front. Difference is previous element, that is 1. And for this very last element, you don't have any other choices but to go to the previous element. So you will go to 2, right? So this is how your close element will look, right? What does this mean? This means that if you are standing at this element, the closest element to you is 1. You can go to 1 with a cost of rupees 1, right? If you are at 2, you can go to the second element with a cost of rupees 1. If you are at third element, you can go to the first element with a cost of rupees 1. And if you are at the third element, you can go to the second element with the cost of rupees 1, right? So this is what the close vector means, right? I hope this is clear to you, right? Now let's see this query. This first query says if you are standing at 3, right, and you want to go to 0. So let's say you are standing at this position. If you want to go to, let's say, 0, right? So first thing first that you should observe is that you can directly jump from 3 index 3 to 0, right? And that will cost 9 minus 0, which is 9 rupees, right? Okay. But the other way would be that you are standing at this position. You can go to index 2 with a cost of rupees 1, right? Let me write it with a different color so that it is a bit clear. Let's take green. Let's say you are this position, you want to go to this position, that will take a cost of rupees 1. Now from this position, you can go to index 1, right, with a cost of rupees 1. Do that, take rupees 1, and then this position throws you back to this position, so you won't be taking that route. You will say, okay, let me go directly to index 0, or rather this element, which will take a cost of 0 minus 2, right? So abstract of 0 minus 2, which will be plus 2, right? So you can come to this index with a rupees of plus 2, right? So ultimately the total cost is 1 plus 1 plus 2, which is 4, right? So query of this element should give you a 4, and yes, it does so, right? Let's look at the other one as well. Let's say you want from go to 1 to 2, right? So 1 is this element, right? And you want to go to this element, right? Let me again change the color so that it is clear to you. So let's take red this time, right? So you are at this position, you want to go to this position, right? And if you look at this, the close is 2, so you can directly go to that with rupees 1. And if you look, the answer is 1 in this case. Let's look at the last test case, which says that you are standing at index 2, right? Index 2 is this one, and you want to go to this, right? So the first thing would be that you take direct route, that is 3 minus 0, that will cost a rupees of 3, right? The second thing would be either you go from this position to this position, that will cost plus 1 rupees, right? And after this you can go from this position to this position using plus 2 rupees, which will ultimately lead 3 rupees, right? So ultimate answer is 3. There is no minimum, both are yielding the same value, so answer will be 3, right? I hope the problem statement is clear to you, right? Now, the first thing to notice in this was the problem state that the array given to you is triply increasing, right? This is a very important part of the problem. If you miss this part, you might have wondered that how is this thing even working, right? Like you might have thought of DP as well. Like I thought that strictly increasing was just a random word, and after a few minutes I realized that oh no, I made a mistake, right? Now why is that so? Let's try to understand. Because see, at every position you are taking rupees 1 and jumping to a position, right? After that you can jump on any position, right? And any position would cost a rupees difference of their numbers, right? Let's say you are taking 3 jumps, right? So 3 jumps from this, let's say this goes plus x, this goes plus y, and this goes plus z. You don't have any idea that which one should you use, right? You don't have any idea which one should you use, right? If you have not thought of strictly increasing, right? But let's say if the array was strictly increasing, right? Let's say 1 3 7 14, right? So if I want to jump from this position to this position, it will cost a plus 13 rupees, right? Now let's say I said I want to jump from this position to this position and then directly to this position. Now what will be the cost? This will be plus 7 here and plus 6 here, which will again be 13, right? Now I said no, I want to jump from 14 to 3 and then from 3 to 1, right? That will cost a plus 11 and plus 2, which is again 13, right? So you can try any possible method, but the jump would cost rupees 13 only, right? Okay, this makes sense to you that why strictly increasing array was beneficial in your head. Okay, now let's think about one more test case. But what would happen, like let's say I'm standing at this position and I directly jump to this position taking a cost of 13, whereas I could have jumped from this position to this position with using rupees 1. And when I saw that there is no direct jumps, but in future there might be a direct jump, right? So you might think what I'm trying to convey is this doubt came in my mind while I was solving. So let's say you are standing at this position 14, you could jump to this using a cost of rupees 1. You came to an index, let's say I, right? After this, there is no direct jump between them, right? There is no direct jump between them. So what should I do? Should I directly jump from this position to this? No, you shouldn't. No, right? Because there might be a position where you would have taken, let's say you jump to this position, took plus 3, and at this position you can take plus 1 plus 1 plus 1 and reach to this position. There might be a case, right? So doing this, that coming to a point and say at I8 index and you see that okay, now there's no path to this, I can directly jump to the index first or the starting index Li, right? That might be wrong, right? That might be wrong. Now what should we do in that case, right? We should to create a left sum vector, right? That you are going from left to right, right? And what will this vector do? This vector will simply store that you are, if you are starting from this index, right, what is the cost to reach to any rth index, right? Okay, and you need to also create a right to left vector. Now why should I create a one more vector? Why shouldn't this vector be helpful enough for me to solve the problem, right? Let's say this problem, this left vector stored that at this position. I will take the example so that you will understand it properly. But you need to trust me that okay, you need to have two vectors left to right, which will go in this direction, and because li and ri can be different things, right? Once it can be 0 and 3, and other time it can be 3 to 0, right? So both are different things. So when we are having 0 to 3, that means we are traversing from left to right. When we are having right 3 to 0, we are traversing from right to left. So you need to take care of these things while you are traveling on your vector, right? Okay. Now let's look at why we need to create two vectors. The initial example which we had, let's say, let me zoom it a bit. Yeah. So what I'm trying to say is, let's first create the closed vector, right? Closed vector was initially means that will be same for every case. 0 for this it will be, no, sorry, not 0, it will be 1, right? So 1 for this it will be 2, for this it will be 1, and for this it will be 2, right? So think of this, while you are traveling from left to right, you will say okay, to reach index 1 I will use just 1 rupees for this one, right? When you are at this position, you will say okay, if I want to go to the next index, I need to use my own money. I can't use rupees 1 over here, right? Rupees 1 is a hack for you, right? But at this position, this says I can go to index 2, then okay, I can use rupees 1, very great. At this position when you are standing, this says that my closest neighbor is this. So if you want to go from this index to this index, you need to spend some money, right? And that money will be rupees 6 extra. Are you getting my point? If no, let me do it again so that you can understand it, right? Give me a second. Okay, let's say I was standing at this position, right? For this position, I can go to index 2 with rupees 1 only, right? And why so? Because you can see the closest to this element is 2, and if you are using the closest, that is a hack for you, and using the closest, you can reach to index 2 using only 1 rupee, as stated in the problem statement. You can read it, right? That closest with cost 1, right? Now, let's say you are standing at this position, you want to go to left to right, you want to go to the next position, right? Going to the next position, you will say, okay, what is my closest? This element's closest is 1th index, right? So if you want to go to this element from this, you want to go to this, that will cost you extra rupees of how much? 9 minus 3, right? Which is 6, right? So this makes sense to you, right? Now let's say you are coming from right to left, right? What happens in that case? Right to left means I said go from index 3, right? Let me again make it 1 2 1 2, right? Now I'm saying from index 3 0 1 2 3, go to index 2, right? Now from going from index 3 to 2, you will say okay, from this element if I want to go to index 2, do I have a closest? Yeah, this element has a closest of 2, right? Now this has a closest of 2, then why not take rupees 1 and not spend extra rupees of 6, right? Spend 6, because see, when you are going from this position to this, it took rupees 6. When you are going from this position to this position, it took only rupees 1, right? And why 1? Because if you are standing at this position says my closest is 2. So go to this element with rupees 1 only. Getting it? So that's why what we will do is we will create two vectors. One is left to right, that will store the cost from going from left to right, and one right to left, that will store the cost of going from right to left, right? And if you have read about something of called PrefixSum, that will be used. It is a very important topic in competitive programming. So if you don't know about it, you should be reading about it so that in future if you have face any problem, that will be helpful for you, right? Now I will do the diagram here using the prefix sum thing, right? Prefix sum of that element, so you don't need to worry about it, but you should learn that topic so that you can solve problems, right? All right, so let's say what I'm trying to say, I will create a close, right? Close will be 1 1 2 1 2, right? And after that, let's create left to right, right? What does this left to right means? Left to right means if you are standing at this position, you will say, okay, my initially my value will be 0, right? From left to right. Now, when you want to go from 1 to 2, you will say, okay, if my array, if this element, right? If I'm at index, this element, wait, let me erase it so that it's clear to you. Okay. What I'm trying to say is, let's say you are standing at this index, right? And you want to come from this element to this element, right? How much will it cost to you? You know that it will cost rupees 1, right? So how will you check? You will simply say if my close of I, right, is equal to close of I minus 1, rather, be patient with me, you will understand what I am doing and why I am doing. If close of I minus 1 is equal to I, that means if my initial vector said that I can go from this element to this element at rupees 1, right? So if my close of I minus 1 is equal to I, which is here the I value is, let me write the I value with a different color, 0, 1, 2, 3, right? Let me erase this as well. Yeah. So what we will say is, let's say you are standing at this position and this position said to go from this, we know that rupees 1 we will. So what we will say, if close of I minus 1 is equal to I, which is true for that case, we will say, okay, it will cost a rupees of 1 plus 1, 0, previous value, whatever the value was, plus 1, right? Let's say now you are at this position, right? Now again you will check if close of I minus 1 is equal to I. Yeah, I is 2 and close of I minus 1 is also 2. That means from this position you can reach to this position using a cost of rupees 1. So what will be the total cost to reach till this index? 1 plus 1. Why 1 plus 1? Because still we are storing from 0th index to come till this index, right? Really sorry for this. You want to come from 0th index to this index, and this cost 1 plus 1, which will be rupees 2, right? I hope I'm making sense to you. Now if you want to go from this position to this position, you will again check if close of I minus 1, which is this, is it equal to I? No, it is not. So how much cost will it take? It will take 9 minus 3, which is plus 6. So 2 plus 6 will be 8. So this is what will be the value for left to right if you want to go from left to right. Let's create one for the right to left as well, right? Right to left. So you will start from the last index, right? And what you will do, initially the value will be 0, right? Now you will be standing at this position and say, okay, if I wanted to come from this position, that is close of I plus 1, if it's equal to I, right? So close of I plus 1 is this. Is it equal to I for this case? Yes, it is. So in that case, I can say it will take only 1 rupees for me. And if you look at this now, if you want to come from this position to this position, this has a close value of 1 only, right? Because it has a value of 2. Close of I is 2. So you can come from that element to this element using 1 only, right? Okay. Let's say now you were at index, sorry, you were at index this, right? Now you will say, okay, close of I plus 1 is equal to I. Yes, close of I plus 1 is 1 and you need only 1 rupees to go from this position to this position, right? So it will be again plus 1, which will make it 2, right? And from this position, if you want to reach to this, right, you will again ask, is close of I equal? No, that is not the case. So that in that case, how much cost will it take? It will take 0 plus 2, which is 2. So initially it was 2, 2 plus 2 will be 4, right? So this is how the prefix sum of, rather this is the concept of prefix sum, that you store the value of every element, right? Now let's take a test case. Let's say query of 3 comma 0. Now see, you are starting from 3 and going to 0, right? In this case, you see start is greater than end. So you are going from this, right? You are going from right to left. In right to left, what will be the answer? Answer will be nothing, but you will check in my right to left vector. Your right to left vector will say, okay, find my answer in big of 1, right to left. Now, why are we doing this? Because if you look at the time constraints of the problem now, it says that nums.length can be 10 to the power 5 and queries.length will also be till 10 to the power 5. So you need to write a solution of DO of 1 for every query so that you don't get a TLE, right? You can't calculate every time for each and every query, right? So right to left will be start point is 3 minus right to left of initial point is 0, right? So what will be my answer? My answer will be right to left of sorry, I did the opposite thing. I need to write it as right to left of start, right? Because start here will be greater value, right, which is 0, and right to left of 4, which will be 4 minus 0, which is 4, right? And if you look at the answer of this, it is 4 only, right? Let's look at one more test case, right? Let's say 1 to 2. Now when you are going from 1 to 2, you are going from left to right. Why left to right? Because 1 is smaller, 2 is better, then it is obvious that you are going on this direction, right? Now let's look at the left to right case as well. So this was 0, this was 1, this was 2, this was 3, and the difference you can simply calculate, that is left to right, right, of end is 2 minus left to right of start, which is 1, right? So 2 minus 1 will give you a 1 back, right? Now let's look at the last test case. Again, you tell me, you are going from left to right or right to left? Absolutely, you are going from left to right, right? So if you are going from left to right, what will be my answer? Left to right of 2 minus left to right of 0. Left to right of 2, you will check the value in your prefix sum. What is the value? Let's see. Left to right of 2 is 2 minus 0 will be 2, right? So if you look at the answer, right, answer is sorry, it's 3. I guess we did a small mistake here. Left to right of 2 will be 2, and left to right of 0 is 0, right? Okay, now let's look at the last thing as well, 2 to 0. So when we are going from 2 to 0, right, the value is decreasing, right? So you are going from right to left, right? Okay, so let's look in the right to left vector. Right to left vector is this one. Right to left vector of 2, this is 0. So what we will do in right to left, we will say right to left of start, which is 4 minus 0. So see, 4 minus not 0, it will be 1, right? So 4 minus 1, that will give you a value of 3, right? So answer for this should be 3, right? Okay, so I hope the dry run was clear to you. Now let's look at the code, right? I hope I made you understand why we were using two vectors, what was the significance of using two vectors, and how we calculated the sum of the value in big of 1, right? Now let's look at the code, right? So we will create a close vector initially. If you are at index 0, then you will say close of 0 will be I plus 1, right? Because for 0, the close is the next element. If you are at last element, the close will be initial value, that is I minus 1, the prior value to it. And else you will find the left, you will find the right. The left and right is nothing but the difference of the both elements, which is left to it and right to it. And if left is less than equal to right, then you will say close of I will be I minus 1, right? I hope how we are calculating close is clear to you, right? And else close will be equal to I plus 1, right? Because they have said that if left is less than equal to right, then the element which is prior to it, right, or the smaller index should be on answer, right? Okay, so now let's look at how we are creating left to right. We are simply going from 1 to n, right? Initially the value stored will be 0, and if close of I minus 1 is equal to I, right, then we will simply say that okay, left to right will be nothing but 1 plus the initial value, right? Else left to right will be equal to uh, left to right will be equal to left to right. Okay, I think I made some mistake at this place. Yeah, sorry. Left to right will be equal to left to right of I minus 1 plus abstract difference of the value which we had, right? So I hope this part is clear to you. Now let's look at the part where right to left is created. Similar thing, what we did is if close of I plus 1 is equal to I, then you will simply add plus 1 and you can reach that. Else you can say that right to left will be equal to whatever the abstract difference of between them plus the next value which we have, right? Now we can create an answer vector, start traversing on all the queries. We have a start, we have an end. We will simply say if start is less than equal to end. Means if start is, let's say, 0, end is 3, that means you are traveling from left to right, right? And if your answer will be calculated from left to right, and simple formula which we used earlier in our dry run as well, else our answer will be calculated from right to left, right? So if we look at the code, the time complexity of the whole problem statement was nothing but big O of n, because we never ran two for loops, right? Big O of n, which is n is the number of queries or number of elements which we had, whatever the maximum value is there, and big O of n plus n, right, which is big O of n only, for creating space vectors for using the PrefixSum, right? So it is closed is also created, so it will be n plus n plus n, which is big O of 3n, which ultimately is big O of n, right? So this will be accepted, right? I will put down the code in the comments. If you have any doubt in this, you can ask in the comments as well. Thank you for watching. If you like it, please do subscribe the channel, and if you didn't like the explanation, do drop why it went wrong, that you didn't like it. And one more thing, I'm creating a Discord server as well, so if you're interested, you can join it as well. Thank you for watching.